Welcome everyone. So this is our 104th live stream geometry. There's one person here besides me so far. I'm sure more are going to join later. And today we will go through problems from the Geometry Math League. So it's a competition in Vietnam. These problems are taken from the years 2011 and 2012. And they all look really interesting. I think they're a good level of difficulty. So if you're watching and you want to join us in the future, feel free to email me at mgreenb801@gmail.com. We meet every Sunday at 8 a.m. U.S. Central Time. All right, so I am going to share my screen. So here's the first problem. We have a triangle ABC where BE and CF are the altitudes, and M is the midpoint of BC. This is M, and let's draw BE and CF. So BFCE is going to be cyclic, and M is the center. This is E and F. And N is the intersection of AM and EF. Okay. So AM is like a median in triangle AEF. So N is the foot of the median from A. This is N. X is the projection of N onto BC. Interesting. And then Y and Z are the projections of X onto AB and AC. And we want to show N is the orthocenter of AYZ. All right, let me finish drawing the diagram. Obviously, AYXZ is cyclic. Let's hide these two. So yeah, AN is a median of AEF. Let's see what else we can figure out. So let me get a little bigger. I kind of like this diagram. Okay. So let's draw this circle right here. It's going to be tangent to, oh no, it won't, not necessarily tangent to BC. But this line will pass through the orthocenter. I don't think I drew point D right. There we go. And let's call this H. That's going to be the orthocenter. All right. So we have like a little parallelogram here. I'm not sure how useful that would be, but obviously these two are parallel and these two are parallel. All right, so how do we show N is the orthocenter of AYZ? I guess one way we could try to do it, it almost looks like YZ is parallel to EF. I don't know if that's actually true. No, it's not. It doesn't look like it. But one way we could try to do that, we could try to show if you reflect N over YZ, that it lies on the circle. So I guess we could first, if at first we want to show AM is perpendicular to YZ, and then once we show that, we want to show that if you reflect N over YZ, that it'll lie on the circle. So those two things would prove that N is the orthocenter. So let's think about that a little bit. So if AM is a median in ABC, then it's a symmedian in AEF. Maybe it'll help to draw that circle, AEHF. So that's going to have diameter AH. I don't know if there's anything special about this point. Maybe GH and X are collinear. That looks true. Let's think about why that is. So angle AGH is 90, and angle AGX is 90. So I think that proves it. Okay, so GH and X are going to be collinear. I'm just going to make that a segment instead of a line. Okay. So maybe an angle chase shows that AM is perpendicular to YZ, because if this is a symmedian, basically we want to show that angle MAC plus angle AZY is 90, and AZY equals ABY. And I'm not sure how to calculate angle ABY.
Which line is the symmedian? I didn't get it.
Oh, AN is a symmedian in triangle AEF. And the reason is because so triangle AEF is similar to.
Okay, I get it.
Okay. All right. So maybe it's worth drawing midpoint of EF. So AI is, I wonder if AI and X are collinear. That looks true also. I'm getting lucky here. So is that obvious? So that means we want to show AX is a symmedian. So basically we want to show AX is a symmedian of ABC.
Yes.
Feels like projected geometry might be helpful. I'm just not sure right now how to see it. So if AX is a symmedian of ABC, what does that mean? How would I prove that? So actually, I think on my YouTube channel previously I did a problem. Trying to remember, where like I let one point be the midpoint of EF, and then I take the midpoint of BC, and then I draw these two. But then I forget what I do with that. Yeah, let me see if I can find that previous video on my channel. Let's see. And I don't think it was that long ago either that I did that video. Looks like we have someone joining. Let me see if he's still connecting. Hey Madhav, thanks for joining. So we are on our first problem here. And it reminds me of another problem I did on my channel. So I'm trying to find that other problem. Let's see how far back that was. Okay, it was a little farther back than I thought. But I'll find it. Just give me a little bit. Here's that problem. I'm looking it up on my phone. Okay, so the problem I did before, it kind of says if x is a point lying inside, if it says, it says that nx should be parallel to AH. So if you look at video 84B on my channel, there's a problem that we solved. But the thing is, we didn't solve it in that video, but we solved it in a later video. And it says it's a very general configuration. So, but you can apply it to this configuration. If you ever have any two Chevians like this, and then you have this segment, and then you draw PO and you take the midpoint, and you draw KL and you take the midpoint. And okay, so it's a little more complicated. You have to draw this and draw this. Then it says that the line. Okay, so the lemma from that video basically says that AQ is parallel to TUT. So basically, however you move P and O, AQ and T are parallel. And so basically, this problem, if you use the lemma, it shows that AH and NX are parallel. But we can't do that. So, but basically, what we could do is we could redefine the problem so that I is the midpoint of EF, and then we could let like X prime be where AI meets BC, and then by this lemma, NX prime is parallel to AH, and so that means X prime has to equal X. So, okay. So that tells us a lot about this. Okay. So then, yeah, we know that we know that this is so AX is like a symmedian of ABC and AM is like a median, and it's like the opposite for triangle AEF. We know all that information. But yeah, let's think about how that helps us solve the problem. I think it would follow from an angle chase then that these are perpendicular, because okay, so from there it's an angle chase, right? because angle ZAV plus angle AZV. So AZV is AX Y, and ZAV is YAX because it's a median and a submedians. So yeah, and those two add up to 90. So yeah, we know these are perpendicular. So we know at least that n lies on the altitude of triangle AYZ. Now we have to show it's the orthocenter. All right. So that's kind of equivalent to saying NV equals VW. Maybe there's another way of thinking about it. So I wonder, I don't think I is the midpoint of AX, is it? Almost, but I don't think so. No. So I guess we could also try to show that angle NZY plus angle ZYA is 90. So ZYA is ZXA. We want to show this as a right angle right here. So basically, we want to show NZ is parallel to both CF and XY. So basically, we want to show NYXZ is a parallelogram. That's another way to say it. Which I think is just, I wonder if this is just the midpoint of YZ. Not sure about that, but let me check. Because yeah, if NYXZ is a parallelogram, yeah. So this should be the midpoint of both. We just have to prove that. And in fact, if we prove that, we didn't even need this, I don't think. So yeah, we could, I guess another way to state that is we could label the midpoint of YZ, and then we want to show A1X is perpendicular to YZ. I'm going to delete this just so I get more letters. But this is video, should be video 84B. So let me write it down. 84B. My pen's not working. Okay. So we want to show, if we take the midpoint of YZ, and we want to show XJ is perpendicular to BC. That would solve the problem. Well, because that would mean NJ and X are linear. Yes, I'm pretty sure that would solve it. Okay. All right, so if J is the midpoint of YZ, can we show JX is perpendicular to BC? Now let's think about what that means. So this is going to be a symmedian. Okay, so we take the symmedian of ABC and we drop two perpendiculars, and then we take the midpoint and we want to show that's perpendicular. That doesn't seem like it should be that hard to prove. I wonder if XJ is a symmedian. I could check that. So I wonder if, basically, I wonder if angle AXY, oops, let me try this. AXY is J or ZXJ. I don't think that's true. No. ZXJ is going to be smaller than AXY. But maybe it's equal to this. Maybe it's HXY. I think it is. Let's just make sure. 42.57. Oh, but that's the wrong angle. Oops, I keep messing up. It's so close. 42.08 and 42.57. Oh well. So yeah, that's not true.
INXM exactly.
Oh, what?
IXMN.
IXMN is cyclic? Oh yeah. Yeah.
Because the right hand.
And yeah, maybe that can help us to, because we want to show NJ and X are collinear. It looks like H also, or I'm not 100% sure if H, no, H doesn't lie on that circle. So let's think about this. We want to show HXJ is a median of XYZ. What would be, so I'm just going to do this really quickly, see what would be the symmedian of that? I take this and I reflect it over this. I don't know if I see anything special with that. Yeah, we can hide, I'm gonna hide a whole bunch of stuff in the figure. All we need is see. Yeah, we don't really need this or this either. Or this. So basically we start with triangle ABC. And X is the foot of the median. Sorry, I'm going to hide a few more things. So we can reduce it to the following. So in triangle ABC, if X is the foot of the median, and then you drop perpendiculars Y and Z, and then J is the midpoint of YZ, then we want to show XJ is perpendicular to BC. It feels like it should be an easy problem, but I just don't know how to solve it yet. We have to use somewhere that AX is the median. So that is maybe not that obvious. So maybe I'll add a little bit more to the diagram. Maybe we could use projective geometry. So, because then YJZ infinity would have a cross ratio of 1. And let's use, I think it's important to use that X, H, and G are linear. I think that might help us. I'm going to add in a lot of stuff that we got rid of. I don't need V and W. I could add the circle. Maybe we could even use something with the Gauss line, because if you look at A, Y, X, Z, I think we're close. And if we take the midpoint of this, And I, J, and O should be collinear by the Gauss line. But yeah, I'm not sure if that's helpful. And it almost looks like IO. Oh no, now it doesn't look like they're collinear. So what did I do wrong? So I wonder, let's say we take the midpoint of AH. I wonder if AH and X, or ANXH is a parallelogram. No, I don't think so, because that would mean these are parallel. Yeah. What's point K actually? Oh, I made it the midpoint of the altitude. I don't want that. If I take the midpoint of AH, and if J is the midpoint of NX, then I would have to let these intersect. They'd probably intersect really far away. And I don't know if that would be useful. One sec, I'll be right back. All right, thanks for waiting.
I think I have found a solution.
Okay.
Okay, we have to prove like ZN perpendicular to AB, right?
Yes.
Okay, we can use a ratio. Okay, ZE over ZC equal BX over XC, right?
ZE over ZC. Yeah. Yes.
And BX over XC equal something because X is the median point, so we have a ratio with EN and NI.
Yes. EN over NF. So ZN is parallel to CF.
Yes.
I see. That's really nice. Okay, so that solves it kind of fast. So we can remove I think most of the figure. All right, but we still need that lemma from before. Okay. I don't know if we need YZ. Well, let's just add it because it says triangle AYZ. Okay. So basically we're letting X prime be this point. So let I be the midpoint of EF. Let AI intersect BC at X prime. So AEF is similar to ABC. That implies that AX is a symmedian of ABC. Okay. And we'll say AX prime. And then by video 84B, which we proved in another video, then we have AH is parallel to NX prime, and that means that X prime equals X. Okay. Once we know that, then we have ZE over ZC equals BX prime over X prime C. So VE, I'll write it like this: EZ over ZC equals BX prime over X prime C, which is equal to EN over NF. And that means that ZN is parallel to CF. Implies ZN is perpendicular to AY. And then similarly, YN is perpendicular to AZ. And that solves the problem. All right, very nice. So yeah, maybe there's a way around using this lemma, but I think it's pretty cool for now. There. All right, thanks. That was fun. So let's move on to the next problem. How do I maximize my screen? There we go. So ABC, D passes through A and is parallel to BC. And we choose a point M on it. I is the incenter of ABC. K and L are the reflections of M about I, B, and IC. So let's draw those angle bisectors to IB and IC. I wonder if it's worth intersecting these two, but we'll figure that out later. So that's going to be K and L. K, L. gonna draw those segments, MK and L. First I'm gonna do, so it says let BK meet CL at N. So that's gonna be farther away. So let me draw those lines of BK and CL. How do I make N a little bit closer? Maybe something like this. So this is N. And we want to show AN is tangent to the circumcircle of ABC. This reminds me a lot of isogonal conjugates. So I wonder if we can use that to help solve this problem. Okay, so I don't even know if it's worth drawing these points, but this is the midpoint of that arc, and this is the midpoint of that arc. So we have CLN and BK and N. Oops. This and this. And let me draw this because to show it's the reflection and also this. So I think I is the circumcenter of MKL because it lies on both these perpendicular bisectors, right? So it should be. Yeah. I is the circumcenter of MKL. I feel like I might have seen this problem before. I wonder if N is the isogonal conjugate of M. I have a weird feeling that it is.
Yeah, it should be.
Yeah. Yeah, I already saw this before, I think. I don't know when, but it looks really familiar. So yeah, if we can show their isogonal conjugates, that should solve the problem by like an angle chase. Okay, so we want to show that. How do we show the isogonal conjugates? We want to show that angle KBC equals angle MBA. And that's obvious. So yeah, I think I just solved it really quickly. Okay.
Yeah. Nice. That's all.
Yeah. So by symmetry, angle KBC equals angle MBA. And then also by symmetry, angle what is it? Angle LCB equals angle MCA. And this means that L and M are isogonal. Sorry, M and N are isogonal conjugates. And then from there, it's just an angle chase. Because then angle NAB equals angle MAC. Which is equal to
ACB.
ACB. Yeah. And that means that AN is tangent to ABC. All right. Hopefully I haven't seen too many of the next couple problems. I don't think I have. I think this one was just different. This one doesn't look that easy. So let's see if we can solve it. So you have a triangle ABC. So really the end center? Or it says let's look at the problem. Let's try it that way. I think maybe they mean circumcenter. So I'm going to try circumcenter and see if it works. And if not, I'll try the end center. So O. So this is O. And then
I think O should be the in center because later I is the midpoint of AE. They are mentioned.
Okay. So let's try the in center. And then H is the orthocenter. So what I'm going to do, I'm going to cheat a little bit. All right, so this is H, and let's call it something else. AD is the altitude. Oops. AO meets BC at E. So that's the foot of the angle bisector. This will be E. Let's call this F. Why not? And then the line through D parallel to OH. We want to see where that meets AB and AC. Yeah, this is where it looks very weird, like taking a parallel to that line. So yeah, there's a lot of information in this problem. Makes it a little confusing. Let me make this a taller triangle, like that. So this is M. This is N. I is the midpoint of AE. And DI intersects AB and AC at P and Q. This is Q. And this is P. And MQ meets NP at T. Wow, this is a little complicated. I don't know if I like this problem, but And we want to show DO and T are collinear. Okay. So that does not look true. So maybe O is the surface center. Let's see. Did I draw everything right?
D O
D, O, and T. So let's see. Triangle ABC, O is the end center, H is the orthocenter, AD is the altitude, AO meets BC at E. The line through D parallel to OH meets AB and AC at M and M. And then I is the midpoint of AE. DI intersects AB and AC at P and Q. And MQ meets NP at T. Let's try. We could just I wonder if we just change the definition of O here to be the center of C, if that will just fix the diagram. Let's try it. Okay, now it looks like the O, yeah, so they must have just written the problem wrong. That was easy. I just changed that in the formula and everything worked. Okay, so
yes.
All right. Let's make it look better. Make these segments. So we have AP and AF. Yeah, everyone else must be used to the old time. So yeah, maybe they'll join in like 7 minutes or something. We'll see. MQ, so MH and Q. Wait, why did I need that? We need to show point T. Forgot about that. So like MQ meets NP at T. Yes. So something like that. All right. PD, I, and Q. Actually, I don't think I lies on that. I think it's just PD and Q, right? Yeah. So that looks okay. Let me see if I can make it look better. It's hard to get a perfect diagram, but I think that looks okay. 1 sec, I'll be right back. All right. So XF, of course, is parallel to BC. So yeah, we have M, N, P, and Q. That's the tricky part here. So M and N are defined by taking the parallel to OH, and P and Q. So we have like these lines DI. We have like this line and this line are defined in like an interesting way. And we see where they cut A, B, and AC, and then they meet at T, and we want to show that DO and T are linear. I wonder. I'm almost wondering if we can use the Gauss line, because D is the midpoint of HX and O is the midpoint of AF. Actually, it's not that easy. So if we take the mid, I'm just going to try something random. We take the midpoint of AH. Actually, never mind.
We don't need the encircle.
We don't need the insert. Oh yeah, you're right. Let's see. So we have DO and T. Yeah, this problem was harder than the others. So yeah, we have to use that I as the midpoint of AE. So basically, if we do like a homothety that takes ADE to AXF, then it takes I to O. I don't know if that's helpful. Yeah, I wonder if there's something special about this line. Pass through some other point. So maybe Desargues' theorem could be useful. I mean, another way to phrase it is we want to show DO, QM, and PN concur, right? That might be an easier way to think about it. So there's like, how do we show three lines concur? We could try to use the radical axis theorem. We can try to use Desargues' theorem. Let me try Desargues. So yeah, we want to show DO, MQ, and PN are concurrent. That's the same as saying that triangles MOQ and PDN. Oh, I wonder if we can just use Desargues here. I don't think it'll be that easy, actually. Let's see. So yeah, I was thinking maybe Desargues on MVP and NOQ. But that would be a little tricky because we don't have NO or OQ. But hey Chuan, or sorry, I'm not sure if you pronounce it that way, but thanks for joining us. So this is our third problem. We got through the first two pretty fast, I would say. So yeah, this one looks tricky. I'm thinking about using Desargues somehow. So yeah, sorry, we started an hour earlier today because in the US they changed the clocks by an hour. But we're still going for another 2 hours. So yeah, this does not look like an easy problem. There's a lot of information here. We have like the parallel to D through the parallel through D to OH, and then the parallel to D. No, and then just the line DI. So if I is the midpoint of AE, like I is going to be the circumcenter of ADE, right? And that circle is going to be tangent to the circumcircle of ABC. And I think ID should be parallel to OX, right? Yeah, because it's just a homothety. So basically we have the parallels through OH and OX through D. So actually that's interesting because I think triangle HOX is homothetic to triangle MVP. And so let's see what that does. I think that's true. So yeah, that's interesting because this is a I think this is a parallelogram actually. And then it's not just that DO and T are collinear. I think all 4 of these points would be collinear. Let's see if that's right. No, that's not true. But this almost does look like a parallelogram. Let's see. So we're saying HM and XP. Is that really true? No, I don't think that's right. So yeah, that's not true. Okay. Yeah, that's weird. I thought these two, are these two homothetic? I thought they were. So we want to see if they can't be. DO. Yeah. Why did I think that? So we know this is parallel to OH, and we know this is parallel to OX, but we don't know that. Yeah, okay, they can't be homothetic because MP is not parallel to HX. Okay. Maybe, I don't know if this is true. No. We know that this angle equals this angle. But we know that this is a parallelogram right here, I think. Yes. And let's see if there's anything special about that. This is a parallelogram, so yeah, GJ is going to be perpendicular to BC. Is G the midpoint of OH? That would make G the 9-point center of ABC. Let's check it out. I think it is. Yeah. So that should be the 9-point center of ABC right there. Interesting. Let me just make sure that's actually true. That is true. And the proof for that, let's see. So HD is equal to DX. So since DI is parallel to OX, then yeah, HG equals GO, and G is the 9-point center. So yeah, it's like we have this parallelogram here, and we want to show the diagonal passes through T. Is there some other homothety we could use? I don't think that's going to do much. What's the best way to think about this? So we could try to show MDX, MDP and QON. We could try to show our perspective. Let me try that a little bit. So that's the same as saying MDP and OQN. So that's the same as saying that this point and this point and A are collinear. So yeah, if we can show K, L, and A are collinear, that's equivalent. Although I'm not sure if that's that much easier. But that doesn't look true, so I must have messed up somewhere. Oh, because L has to be, I drew the wrong point L. Yeah, if we could show A, K, and L are collinear, that also solves the problem. But it might make it more confusing, so I don't know. Or maybe not. Let's think about that. That would be the same as showing. That would be the same as showing that M, D, K, and N are harmonic. I think. Maybe not. No, that would be the same as showing that D, L, I, Q is harmonic. Okay. I'll see you next time. Take care. Thanks for joining. All right, Chuan. I'll see if anyone else can join.
Well, now they all leave me.
How what?
I mean, now there is only 2 of us.
Yeah, now it's only 2 of us. So let me see. I just posted on Discord to see if anyone else can join. But yeah, if you have to leave, it's okay. But yeah, just let me know.
I'm all right.
All right. So let's see. Someone on Discord is posting. Let's try another problem. Some of them looked a little easier. So yeah, this one was pretty easy. We solved it pretty